Okay, you are welcome to Tutorials with From Eternity the School Board. So we are going to take a look at chemistry. We start from the beginning of the subject, chemistry, introduction to chemistry. And what is chemistry? What is chemistry? What is chemistry? We have, as I said in our biology class, we have pure sciences. We have pure sciences. The three main pure sciences. We have biology, chemistry, and what? Physics. Biology, chemistry, and what? Physics. Now, they are called the basic pure science. Pure science is the basic science because upon them, they are the bedrock. They are the bedrock of other applied sciences. They are pure. They are the bedrock of other applied what? Apply what? Sciences. Now, what is chemistry? What is chemistry? Now, so chemistry is one of the three main branches of what? Pure science. So what is chemistry? Chemistry is a pure science that deals with what? Composition, properties, and uses of what? Matter. Chemistry is a pure science that deals with what? Composition, properties, uses of matter, and even what? Is also studying the changes that matters what? Undergo. Am I communicating? Yes. Chemistry studies the composition, properties, uses of matter. It also studies the what? Changes that matters what? Undergo. Now, what are matter, or what is a matter? We know that one now. What is a matter? And occupies space. Are you a matter? Yes. Matter is anything that has mass and what? Occupies what? Space. So, chemistry is life. I used to tell people that chemistry is everything. Chemistry is what? Everything. Starting from as a human being, starting from your hair to your toe is chemistry. Everything in your body is chemistry. This chair you are sitting on, everything there is chemistry, because this chair is made up of wood, and wood made up of what? Combination of polymers. And if you break it down, to come down to what? Carbon, hydrogen, and oxygen. Even your body, your hair, from your head to your toe, if you break it down to the simplest level, you come down to atoms, elements. It's atoms that build up to make you. And where do we study this? It's not in chemistry. That's why I said that chemistry is what? Even this fan is made of metals, alloys, or what have you. If you break it down, it comes down to what? Elements. This marker I'm using, even the ink inside, organic compound, still come down to what? Elements. Carbon, hydrogen. Nitrogen can enter depending on the nature of the what? Of the matter. Phosphorus can also enter, but basically it comes down to what? Atoms of elements. So that's why I say chemistry is everything. Because chemistry studies what? Matter. And matter is anything that has mass and what? Occupies what? Space. Now, the same scientific method I described when I introduced biology is also obtainable here. The scientific method. We define scientific method. Then the same thing, the same way you have observation. If you, as a scientist, or you observe a natural phenomenon, and you want to, from what you at that particular point in time, what you notice that at that particular instance will help you to formulate what? Hypothesis. That hypothesis is just a statement made based on what you observe. It's not true or false. You just observe it, but you need to test it. Through what? How do you test your hypothesis? By conducting what? Experiments. So if you now conduct an experiment, if the result of the experiment is in line with the what? The hypothesis, then that means the hypothesis is what? Correct. Then this will take you to what? Theory. But if you have a negative hypothesis, if you have a negative hypothesis, you go back to if you have a negative, if the experiment gives you a negative result that is opposite to the hypothesis, or not even in line with the hypothesis, you go back to your hypothesis and observe again, you observe again and modify your hypothesis, or you may even get an entirely new hypothesis and test it again. If it's not correct again, you go back. This is what you keep doing. The same way, but see, if the hypothesis is positive, that doesn't mean that you rush to it to become a theory. There are room for other scientists to further experiments on that particular concept. And if it's consistently showing that the hypothesis is correct, if it consistently gives positive results, then that's when it will get to what? Theory. Am I communicating? That's when it will get to what? Theory. So then after, with series of other works, maybe when it has been tested, it keeps showing the same, more experiments are being conducted, and is consistently showing the same thing, especially when the theory has been tested again. The theory has been, before you go to theory, it's the hypothesis you are testing now. But when it is correct within the limits of any available evidence, it becomes a theory. Now, after the theory, more tests will be done on that by other researchers on that particular theory. And if it's consistently proven to be true without any exception, it becomes a what? A law or a what? Principle. It becomes a law or what? Principle. It becomes a what? A law or a what? Principle. Remember, I said that if the experiment gives a negative result, then the scientist will go back to his what? Hypothesis. You either modify the hypothesis or you put forward a new what? Hypothesis and continue the test. So this logical way of studying problem, this systematic way, is called what? Scientific what? Method. In fact, scientific method is the foundation for scientific what? Research. Scientific method is the foundation for what? Scientific what? Research. By the time you come up, you start studying journal articles, start writing your project and other things. You start seeing journal articles published. There are some articles that are from the first principle that the person was actually the person that observed this thing and did the experiment himself. Not that he made a review of some other person's work. No, there are some that the scientist did this research from the scratch himself. That's when you appreciate this what? Scientific what? Method. Any question on scientific method? So I've used chemistry and biology now to explain what we mean by scientific method. So this is what scientists do to be able to come up with what they call law and principles of today. Now, how do we use chemistry? Do you think chemistry has any role to play on our everyday life? So where do you think you can use chemistry? From your own understanding, where do you think we can use chemistry? Pharmacy, how? Pharmacy. Okay. Drugs. Okay. So, when it comes to food, in fact, everything is chemistry. Tell me, when it comes to food you eat, what are they? Are they not chemicals? Are you aware they're chemicals? Yes. But most of the things we eat, but we advocate for natural ones, organic ones, right? Organic ones. But they are still what? chemical. There are still atoms, elements that make up this, even the organic food you eat. True of us. Even the fertilizer you use in the cultivation is made up of what and what? Do you know what made up fertilizer? NPK, nitrogen, phosphorus, potassium. True of us. You don't know. So these things are chemicals. So have you now seen that chemistry is everything, even in food? Now let's go to the clothes you wear. Let's go to the clothes you wear. Even the clothes you wear, fiber, the textile fibers, the clothes you wear are made up of different chemicals. Hope you know. Elements, are you aware? Yes, if you break it down, it's still what? Most of them there are some from wools, there are some from natural fiber, there are some that are synthesized, but in all, they are still what? Made up of what? Atoms and what? Elements. Even in the military, when it comes to military and the space warfare, the bomb they use in fighting wars are made up of what? Some atomic bomb, missiles, gunpowder. Are they not chemicals? Even the gun, metals, wood, some part of it that may be wood, some part of it that may be metal. Are they not 6 chemicals? So the knowledge of chemistry is also needed in those what? In the production of what? Manufacturing of what? The weapons, bullets, guns, and what have you. True of us, bombs. Have you not seen it now? Even in space, in the aeroplane, what alloy do they use in the production of the body of aeroplane? It's light. It's light. What's the name? Do you know? You don't know. You don't know. Okay, don't want to get there. Apart from the what is it called again? Apart from the what is it called? The body, the aeroplane itself, the science of airspace, what happened there, has a lot to do with also what. Even rockets. This rocket they fire from here to the, even though its physics is also there, but the chemicals, the whatever you can feel in that rocket has a lot to do with what? Knowledge of what? Chemistry. Even in housing, the cement you are using to build your house is not chemical. The block, the sand is are you aware that sand is a compound? Sand is a compound, are you aware? It's a compound. It's not a mixture. What is a mixture? Is soil. Sand is a compound. We get there when I will talk about what the name, the actual chemical name for sand. So these things are what? Chemistry. From there, knowledge of chemistry, you talk of what you use in build, the wood you use in building the door, constructing the doors, the upholsteries, even the wire for through which you use to connect your what? Light. You bring power into the house. The bulb itself, everything is chemistry. So housing that also there. Even of course medicine, you know now. Pharmacy, medicine, drugs, medical equipment. Still, knowledge of chemistry is also what? Involved. In transportation, the fuel you are using is hydrocarbon. It's not hydrocarbon. The tire is the parts of the vehicle you are using, all of them boils down to what? Chemicals, chemistry. So chemistry has a wide range of what? Uses. So these are the areas where knowledge of chemistry is applied. So does chemistry have any adverse effects? Yes. Pollution is there. True of us. Industrial pollution, industrial waste, and also knowledge of chemistry. When this is metal, right? Iron. If you expose this iron to moisture, what will happen for a long time? Rusting. So rusting is the chemical process, is the chemical change. We still talk about chemical. Remember, we define chemistry as this branch of pure science that studies what? Matter by way of its composition, properties, uses, and even the changes. We have physical and chemical changes. We should talk about that chemical change, okay? So this that one where rusting of metal is a chemical process. So that is also an issue with chemistry. Now, the drug that have been produced through knowledge of chemistry can be also what? Abused, true of us. If not well used, it can be abused, true of us. If the drug is not that is meant to take care of ailments, can be abused. Drug used to produce medicine can be abused by people using it raw, and is dangerous to what? Health. These are areas where people can make a kind of use take advantage of their knowledge of chemistry in a negative what? Side. So these things are the adverse effect. That is when not well used. Now, what are careers? What do you think you can get from chemistry by your knowledge of chemistry? What type of career do you think you can build with your knowledge of chemistry? Number one is what?
Pharmacy.
Pharmacy. Italo pharmacy, Miss Pharmacy. Now, pharmacy, yeah. Pharmacy, you can build a career in pharmacy. Chemistry, health generally, health services, medical doctors, pharmacists, nurses. Your knowledge of chemistry, that's why you need to credit your chemistry before you enter here. You enter and go and say you're doing nursing. It's not that you, maybe if you go to second year, they're asking you, but the question you will see, the things you will see will be an applied knowledge of these basic sciences. That's why you should be grounded in them before you enter any of the healthcare professional courses. If you don't do that, you have issues. In fact, your patients are at risk. Now, so pharmacists, biochemists, chemists, even nutritionists, because knee is also what? Chemical. Dietitians, doctors, nurses, medical assistants, name them, even laboratory assistants can build a career. Or someone that is knowledgeable in chemistry can build a career in this area. Even in teaching, like me now, I'm teaching now. I'm in two aspects. I teach. I'm also a what? Pharmacist at the same time. Now, if I didn't build myself in chemistry, do you think I'll stand here and talking about chemistry? I wouldn't even have the confidence to do it. I would not have the confidence to do it. That's the fact. Okay. Now, so in teaching services, there are also we have chemistry teachers and lecturers in different schools, from secondary school, polytechnics, universities, and what have you. Then food processing, true of us. Yes, you can build a career in food engineering. You can study to become a food engineer or food technologist with a knowledge of what? Chemistry. Then even in petroleum industries, petrochemical and petroleum. Well, what are petrochemicals? Petroleum is that crude oil. Gogo is petroleum. Then from there, if you through the process of fractional, we still do separation techniques. Through the process of fractional distillation, you can fractionally distill petroleum, crude oil, to produce different other components. Now, this component, name them. Some come out of it. Coal tar is there. The premium motor spirit, the one you call fuel, is also there. Name them. Gasoline, even the gas you used to cook is from crude oil. If they distill it. With most of the petrochemical, then we have petrochemicals. Those ones are what you produce from petroleum products. Like now, something like gallons. Gallons are petrochemicals because it's what you get from petroleum that you use to produce gallons. It's an example of what? Jerrycans now, they are petrochemicals. So those in petrochemical, you can build a career as a petroleum engineer or petrochemical engineer or any career in that line. So even chemical engineers, yes. Now, manufacturing industries, yes, you can do a career. Even chemical engineers are also in manufacturing sphere. True or false? True or false? Because they are the one that chemical engineer talk about these metals, what you can manufacture, process it from the ore and what have you. All these things you see. This metal rod they use in the building and the iron, they are from what? Research. They are from the what? From the metallurgical industries. Am I communicating? Am I communicating? You call it metallurgical what? Industries. Now, even cement, because cement is also a manufactured product, yes. Now, even in extractive industry, you can build a career. Those people that extract metallic ore from the even the crude oil miners are also there. Even geologists can build a career in the extractive industry. Now, agriculture, of course, you don't need to do that one now. Agricultural scientists should have knowledge of what? I'm not talking about most farmers that don't even go to school. That one. I'm talking about scientists that do research on agriculture. I'm talking about scientists. Go. Someone that doesn't have basic knowledge can still be a farmer. You are just farmers. You're not agricultural scientists. Agricultural scientists carry research. But you can also be an agricultural scientist and at the same time be a farmer. It's your choice. But the main thing is that it's not all the farmers that is knowledgeable in chemistry enough to do all those things. Because okay, those ones that go and buy seed, and buy fertilizers, are they the ones that produce fertilizers? They are produced by those knowledgeable in that, know the type of chemical they combine to give a quality of fertilizer that will help the plant to grow. These are what they carry out, they discover through what? Research. And what they can do to make the crop to yield. A scientist or even somebody that is in crop production, these are the ones that know exactly what and what to do to make the disease into yield. They are the ones that advise farmers on what and what to do for a yield in their products. Then even in forestry, you can build a career in forestry. Those people that go to study give me an example of a forest product.
Of a forest product.
Timber, good. Clap for yourself. Good, yes. And that one is what? Wood.
Book.
Pepper. You don't know that pepper came from wood? You don't know? Know it today? Yes, pepper came from wood. They process it.
What about
Cotton is also is it really forest? Okay. But we have plants they call wool now. I hope you know wool plant. Yeah. Although most of the wood now not all the wools come from some are synthesized. I hope you know. Because I don't know how many plants that will yield the amount of wool they use in the world of today. So this is a kind of introduction to what chemistry is all about. So with this basic knowledge, we proceed to another aspect of chemistry. Now let's start. We talked about matter, right? That chemistry, in fact, from definition of chemistry, it studies what? Matter, simple. So now, what is that matter that chemistry studies? So let's look at matter. What is a matter? We are defining that a matter is anything that has what? Mass and occupies what? Space. Remember where we started? We started from chemistry. Is chemistry that called matter name? Because chemistry called matter. Say, I am chemistry, I study matter. What I study is what matter contains, composition of matter, and uses of matter, properties of matter, and changes matters do what? Undergo. That will now lead us to what? Matter. Everything is matter is everything. So now let's look at matter. From there we now kick off. Now what is matter? What is matter? Matter is anything that has what? mass and occupies space. So by this definition now, it's clear that matter is almost what? Everything. And matter is everything because almost everything in the universe is made up of what? Matter. Give me examples of matter you know. You have plants, animals, so you are the matter. Plant animals around us are what? Even the food you eat is a matter. Food is a matter. Does it have weight? Does it occupy space? So food you eat is a matter. Even the water you drink is a matter. Even the air you breathe is a matter. Air has weight. True of us? It does. Air is also a what? And air occupies a what? Space. So the air you breathe is also. Even we ourselves, 2 of us, 3 of us, 20 of us, millions of us, we are what? Matters. We are what? Matters. Now let's continue. Now, there's something that will make you to appreciate what is mass of a substance. Can you define mass? What is mass? Define mass. What is mass of a substance? Any idea? No. Mass, even though mass and weight are related, but mass is not the same thing with weight. So don't call weight. What is the mass of a substance? If you ask now, even though this is not a physical, but it's important, you understand something, the link between mass and matter. What is mass? What is the mass of a substance? Good. Now let's define mass of a substance. It will be able to appreciate what mass is. So what is the mass of an object? Mass of an object is the quantity of matter the object contains. Mass of an object is the quantity of matter the object contains. So the quantity of matter in an object contains is the mass of that object. Now, a very important, I want to distinguish between mass and weight. Now, I'll still talk about this in physics. Mass and weight are not the same thing, but they are related. Mass of a substance is the quantity of matter a substance contains. Now, mass of a substance is the same thing everywhere. Everywhere, anywhere, your mass is your mass. You cannot come here, your mass will change. You go there, your mass will change. No, your mass is your mass. And mass, in chemistry here, mass, the basic unit of mass is mole. The basic unit of mass is mole, but due to practical purposes, it's in kilogram. But the basic unit of mass is moles. But for practical purposes, it's measured in what? Kilogram. For practical purposes, it's measured in what? Kilogram. But the basic unit of mass is what? Mole. That's the basic unit of mass. Now, as I said before, now mass is what? The same thing everywhere. Now, let me now distinguish between mass and weight. I say that mass and weight are not the same thing, but they are what? Related. The weight of a substance depends on its mass. The weight of a substance depends on its what? Mass. So the weight of a substance measures the gravitational force on that what? Substance. So weight is a force, but mass is not a force. Note this point. Weight is a force, but mass is not a force. That's why basically, even though in chemistry sometimes they interchange, they'll tell you that the weight of a substance is maybe 20 milligram or 20 kilogram. That is not actually the actual meaning of weight. Weight is actually measured in Newton, but it's a force. Are we together?
Yeah.
Weight is actually measured in Newton because it's a what? It's a force. It's a force. Because it's the gravitational force acting on that what? Substance. So that's why in physics they will tell you that the weight of a substance is by formula, they say that weight of a substance is what? Mass times what? Acceleration due to what? Gravity. Have you come across the formula? That's why in physics they will tell you that the weight W is equal to mg. Weight, mass of that substance times what? Acceleration due to what? Gravity. That's what they will tell you. So that means That's why weight of a substance is not the same thing everywhere. Because are you aware that the acceleration due to gravity varies in different parts of the globe? Are you aware? It's not the same thing everywhere. So that's because acceleration due to gravity is not the same thing everywhere. That's why the weight of substance is not the same thing everywhere. Because if you multiply that mass, which is constant, by acceleration due to gravity, so the weight a substance assumed in a particular place is changed as changes are the acceleration due to gravity in that place changes. So weight is not the same thing everywhere, but mass is the same thing everywhere. So I just did a kind of explanation for you to understand where we are going to. So whether you talk of weight, whatever you use balancing. We did balancing now. Use balance to check the what is it called? The mass or weight, as the case may be. Now, having established what matter is, now let's look at. Remember what chemistry studies. It studies composition, properties, use of matter, and changes that matter undergo. We have talked about the concept of matter, what matter is. Now, before we go to composition, let's look at the properties of matter. Remember, you see that we are taking it bit by bit, right? We are dismantling chemistry. Properties of what? Matter. So if you are asked now to define the concept, what is properties of, what you understand by properties of matter? Basically, properties of matter are those characteristics that matter possess. Simple. Properties of matter are those characteristics that matter does what? Possess. Simple. Then what are those characteristics? What are those characteristics that matter do what? Possess. Remember, matter is something that has weight and what? Occupies what? Space, right? Good. If you see, let's say if you get salt now and keep salt is a matter, right? You look at salt. Salt is what? White in color, right? It's a property. It's not a property. Like table salt, like sodium chloride. Sodium chloride is white in color. It's a property, right? If you put it in water, it will dissolve. It's a property, right? Good. Like sand. Sand is a matter. Sand, if you put it in water, it won't dissolve. It doesn't dissolve in water. It's a property, right? So these things are what characteristics that what matter does what possess. That is make up the what makes up the what properties of what matter. Now there are two properties of matter. We have physical properties and what chemical properties. There are two properties of matter. We have physical properties and what chemical properties. Physical and what chemical properties. Chemical what? Property. Even though we talk about the physical change and chemical change, but chemical properties are those properties that are associated with physical. We are starting with what? Physical property, right? Physical properties of matter are those properties that are associated with what? Physical changes. When we discuss changes that matter undergo, we explain physical what? Changes. But just let's note that one. Any property that is associated with what? Physical change is a physical property of that what? Matter. Now, I think let me talk about physical change. No. I will discuss it as a subtopic. Now, any changes any property that is associated with physical changes of matter is known as what? Physical property. Examples of physical property, these are the ones like now. Example now. Good boiling point. I like that. Does boiling point have anything to do with physical change? Because as your body is changing, good. So we have boiling point. I like that. Boiling point is a physical property. Melting point. These are physical properties, right? Boiling point, melting, even density. Density is a physical property, right? Hardness. We have boiling point, melting point, density. Boiling point, melting what? Point. Density. Even hardness. Hardness is a what? Physical what? Property. Malleability. Do you know what is malleability? When you say that a metal is malleable, what does it mean? It's malleable. Is what? Malleability. Okay, bring it to Igbo language. Okay? So malleability is a what? Physical what? Property. Then physical property are not only those you can feel or see, even those not only those you can see, those you can feel is also a physical what? Property. Something like what? Color. Am I correcting? Those you can detect by senses. Okay, how do I put this now? You know that when you talk of something like a boiling point now. Can you detect boiling point by your senses? What are senses you know? Sense of what? Senses now. What are the sense organs in your body? Nose, mouth or tongue. Okay, mouth, okay, tongue. What else? Skin, okay. Now, those ones I called boiling point, density, hardness. What have you? It's not by senses. You measure them. True or false? You measure the boiling point. True or false? You read it. True or false? Now, but there are some you can also detect with your senses, like color. If you look at this, you can see the color. So it's also a physical property. The one you can detect with your odor, with your sense organ, your nose, you smell it, it's odor. Even the taste. So these are the ones we say that we detect with what? We are sense what? Organs. So we are senses. These are what? Physical properties. Both those you can detect with sense organs and those you can do what? Measure. Can you measure the color of salt? You see it, right? Now, these are physical properties. Now, what are chemical properties? Just as the same way physical properties associate with what? Physical changes. The same way, chemical properties are those properties of matter that associate with what? Chemical changes. We will discuss chemical changes in detail so that you understand it better. I just want to introduce it because this is the bedrock or whatever. If you miss this place, you won't understand chemistry. That's why I'm taking my time like this to explain it. So chemical properties are those properties that are involved with when matter change from to form a new what? Substance. In summary, we can say that chemical properties are those properties that are get involved when matter change from one's form to a new substance. You know, when we discuss chemical change, if we talk about chemical change now, I will explain this thing I said now well when we discuss what? Chemical what? Change. Just know that chemical changes is associated with what? Chemical properties of what? Matter. Simple. Are we together? Let me not confuse you for now. Just know that chemical properties are those properties of matter that are associated with what? Chemical changes that matters undergo. What are the examples of these chemical properties? Let me hear you. Suggest, what do you think should be the example of these chemical changes? Good. Rusting of what? Iron, because a new substance is what? Formed. So don't worry, when we discuss these changes that matter undergo, Eh? Eh? Burning good. Burning good. Burning, how it burns in air is a chemical property of a matter too. Even its reactivity, reacting with other substances to form a new substance, is the chemical properties of that word. That's why when they discuss a particular, like now, they'll ask you in chemistry, what are the physical properties of oxygen? You say oxygen at room temperature, boiling point, it does this. It has the density of, so these things are physical properties. But when they ask you the chemical properties, you start saying it reacts with hydrogen to form it helps in combustion. It reacts with it rusts iron. When it comes in contact with iron, it oxidates it. This is like what? Chemical what? Properties. I don't want to go deep there. So now, with this at the back of our mind, I don't know if you have any question for now. The next place you want to enter now is you want to enter changes that matter undergo. So I don't know if you have any questions. Or before I go to changes, I want to talk about what? Composition of matter. Composition of matter before I talk about there's something else that I missed in this definition. Classes of matter. Good. Very important. Classes of what? So chemistry studies composition, meaning. Hello? Meaning of what? Matter. Composition of what? Matter. Properties of what? Matter. Uses of what? Matter. Changes that matter undergo. And classes of what? Matter. Yes, I forgot that one. So how many are they? 1, 2, 3, 4, 5, 6. 6 things you should know that chemistry does what? Study. It studies the meaning, composition, properties, uses, classes of matter, and changes that matter. So you can have an elaborate definition now that chemistry is a pure science. You don't need to cram it. If you understand it that way, they ask you, what is chemistry? You start rapping. Chemistry is a pure science that studies the meaning, composition, properties, uses, classes of matter, and changes that matter undergo. This is a complete definition of chemistry. So let's talk about composition before we go to what? Classes of matter. What does matter? What are the composition of matter? Matter is composed of one or more of the following elemental particles. So the elemental particles that matter is composed of are as follows. Are you there? The elemental particles that matter is composed of are as follows. We have them: atoms, molecules, and what? Ions. Atoms, molecules, and what? And what? Ions. Atoms. These are composition of matter. Some matter may just be only atom. Some may be what? Only what? Some may be what? Ion, depending. True of us. So this is composition of. There are some matter you see they compose of only molecule. Like sodium chloride. Is it a matter? Sodium chloride, is it a matter? Yes. What is it composed of? Molecule. Sodium chloride in water. You have what? Sodium ion and what? This compound, is it electrovalent compound? Is it covalent compound? Sodium chloride. Is it covalent compound? Don't worry, we'll still talk about bonding. Let me not go there. Just let's leave it at this level. By the time we'll go into it deeply. You understand what you understand this question. Let me not put you there, but just understand that matter is composed of what? Atoms, molecules, and what? Ions. Okay, now let's continue. I think we have just 2 minutes to go. I think we will round off here. In our next class, we'll continue from this one this uses is continuous. When we pick each matter, we can talk about the uses, okay? But where we want to go into now, after in our next class, we'll start with changes that matter undergo. In our next class, we'll start with changes that matter undergo. After changes that matter undergo, we'll now talk about classification of what? Classes of what? Matter. So in our next class, in chemistry, we'll start with changes that matter undergo. Any question? Do you have any question? Do you have any question? Okay, in the absence of any question, we stop here for today. Thank you very much for today's class. Make it a point of duty to always come to class on time, and ensure you study what we discussed today, and go to past questions, feature questions from this topic, and solve them. All right, see you next time.